Let's continue, people. Today we start with the next atomic model, which is Bohr's atomic model. Out of all the models that we have done, Thomson, Rutherford, the most important from an examination perspective is Bohr's atomic model. Okay. Bohr's model partially picks up from Rutherford's experiments. We can also say that some of these assumptions were also a start towards the next phase, which is of quantum mechanics. So that initiation towards quantum mechanics starts somewhere from Bohr, and Niels Bohr was also a big part of developing quantum mechanics along with Schrödinger, Heisenberg, and many other physicists. What exactly is Bohr's model? So what we have to first understand is the model that Bohr proposed is first for hydrogen and hydrogen-like species. We are writing different postulates of Bohr's model or different points, and let's understand the first postulate. We'll divide this into multiple different postulates. हर एक postulates का there is a really big explanation, तो समझ के करना. The first postulate is Bohr's model is applicable only to hydrogen atom and a hydrogen atom like species. What does that mean? Hydrogen atom has how many electrons, people? 1. Okay. I want helium to be hydrogen like. Helium has how many electrons? Helium has how many electrons? 2. I take that 1 electron, I remove 1 electron from helium. क्या बन जाएगा वो? Helium cation, He plus. This is called as hydrogen like. Hydrogen has 1 electron, He plus also has 1 electron. Which is the next element? Lithium. How many electrons does lithium have? 3. I want it to become hydrogen like. How many electrons will I remove? 2. After lithium, beryllium. Number of electrons? 4. I want it to become hydrogen like. How many electrons will I remove? 3. What about boron? And so on. So the first thing is the model is applicable only to hydrogen and hydrogen like species. All of them containing only 1 electron. And the reason for that is why this model was applicable only to hydrogen, or why was in the first place developed. When you just have a nucleus and an electron, which is the only force in between them? Is it the force of attraction or the force of repulsion? I repeat, I have nucleus and I have electron. What is the force in between them? It is force of attraction. And hence, Bohr had to work upon only one force. The moment you add multiple electrons, so nucleus और electron के बीच में क्या हो जाता है? There is a force of attraction, they are oppositely charged. And electron के बीच में what's the force? Repulsion. Then multiple different forces come into picture. And hence Niels Bohr's model was thoda sa for a simplified version where there is only one force acting, which is the force of attraction. With me till here? So the first postulate is Bohr's model is applicable only to hydrogen and hydrogen-like species. Now the second postulate. Let's say this is the same hydrogen atom. What is present in the center of the atom? Nucleus. Charge on the nucleus, people? Positive. What is revolving around the nucleus in circular orbits? Electrons. So let's say this is that electron which is revolving around the nucleus in circular orbits or elliptical orbits. Now, what is the force between the electron and the nucleus? So the nucleus is trying to pull the electron towards itself. इसको क्या बोलते हैं? We call this as the force of attraction. The same question was asked to Rutherford. If you remember, we go back to the first limitation. What was the first limitation? That according to Maxwell, if an electron revolves, it should eventually spiral into the nucleus. This explanation as to why this doesn't happen is explained in two different postulates. First, yes, there is a force of attraction between the electron and nucleus, but there's another force which a body feels when it is in a circular motion. For example, let's say we are all, let's say in a car or bus or any vehicle, and we take a turn. What force do you observe? Let's say if the car is going right, our body tends to move in the opposite direction. I don't know if you felt it or not. What is that force called as? Anyone knows? 10th standard may be the year. The force which acts inward is centripetal force. The force which acts in the outward direction is called as centrifugal force. So the force of attraction which is present between the electron and the nucleus is balanced by which force? A force which is acting outwards and which is called as centrifugal force. Did you people get that? Okay, 10th standard, I think you just had the name of the force. Did you people have what is exactly the formula for centrifugal force? ठीक है. Centrifugal force का formula है, centrifugal force is mv squared over r. That's the formula for centrifugal force. Now, what is the force of attraction between the nucleus and the electron? Are both charged particles? Let's say this is the radius of the atom, so I put that as r. We've done the same thing. Yes, we did the same thing yesterday. Let's say this is your nucleus, this is the electron. The distance between them is, let's say if I call this as particle q1, I'll call this as particle. What will be the force of attraction between them? Force of attraction will be K q1 q2 over r squared. How much is q1? ध्यान से देखो वापस से. What exactly is q1? What exactly is q1, people? Nucleus. What's the charge on the nucleus? Please go back, notebook mein check karo. Excellent. What did we write the charge on the nucleus? How much did we write nucleus pe charge? In terms of atomic number, we wrote how much did we write the charge in terms of the atomic number? Excellent. Anyone else, people? हमने लिखा था Q1 as alpha particle, Q2 लिखा था as the nucleus of gold atom. Then उसके बाद क्या लिखा था? Nucleus has Z number of protons. Each proton carries a charge of how much? 1.6 into 10 raised to minus, जो हमने just represent किया था as E. We are more interested in the magnitude. क्या मिला people? Z into E. So what is, how much is Q1? ZE. What is Q2 over here? It is just electron. The charge on electron 1.6 into 10 raised to minus 19 coulombs. We'll also take the magnitude, we'll take that as E. Did you will get that? Substitute that here. So what is the force of attraction? K. How much is Q1? ZE times Q2 E over, that's force of attraction. This.
We won't take negative.
No, we're just looking at the magnitude. Centrifugal force is how much? mv square over r. This is the second postulate. Now दोनों को equate करो. Therefore, K Z E times E over r square is equal to, how much do we get over there? mv squared over, ऐसे लिख सकते हैं, you can further simplify this, K Z E squared over r square is mv square by r. There's an r here, there's r square, so we get K Z E square upon r is equal to mv squared. We need this to calculate radius and velocity. Did you will get that? Yes or no? Write on a new page. Bohr's atomic model. Okay, now the third postulate. Going back to the limitations of Rutherford's model, the limitation said that whenever a charged particle moves around another charged particle, it will lose energy in the form of radiation. That was a limitation जो Rutherford को बोला था. Bohr said that no, it doesn't work like that. Bohr said that there are certain orbits in which when the electron revolves, electron doesn't lose energy. Such orbits are called as ground states or stationary orbits. Bohr said that the angular momentum of electron is quantized. Let's understand this statement. First of all, can anyone tell me what do you mean by momentum? What do you mean by momentum? Or your momentum ka formula till you have done till 10th standard. What exactly is momentum? Momentum is mass times velocity. Momentum is mass into velocity. And I think you've done linear momentum abhi tak. Want to understand example ki what exactly is momentum? Let's say you're running down a slope. Can you suddenly stop when you're running down a slope? No, because your body has already gained what you call momentum. जितना ज़्यादा mass उतना ज़्यादा momentum या जितना ज़्यादा velocity उतना ज़्यादा momentum. Now when you have the same momentum in circular motion, I repeat, when you have the same momentum in circular motion, we call it as angular momentum. For example, hypothetically, let's say you are on a swing in a garden. From swing में you supply energy, you use gravity and you start to swing. Theoretically, let's say you keep on supplying more energy. What will happen? This motion will be then called as angular momentum. Bohr said that only those orbits are possible. If I consider these as like different orbits, around the nucleus, with the one which is closest is called as ground state, जहाँ पे n is equal to 1, n is equal to 2, and so on, n is equal to 3. Only those orbits are possible where the angular momentum, mass into velocity into the radius. So for example, हमने जब वो swing का example लिया, the stylus here becomes the radius, where the mass, velocity and radius का product is a multiple of nh over 2 pi, where n is your orbit number, h stands for Planck's constant, m is mass of the electron, v is velocity of the electron, and r is the radius of the orbit. Knowing the mass and velocity, uska derivation karenge abhi, you get the radius of these different orbits. Now, let's say if the electron is present in the first orbit. Let's say this is orbit number 1. ये आपका nucleus है, this is the electron. Let's say this is the second orbit. If I supply energy to this electron in the form of a photon, I repeat, if I supply energy to the electron in the form of a photon, the electron which was present in ground state gets excited and it moves on to a higher state. This phenomena is called as excitation. I repeat, it goes from ground state to this is the higher state. N is equal to 1, n is equal to 2. You can call this as the first excited state. What I did is I supplied energy to the electron in the form of a photon. We know that the energy of the photon is hc by lambda. Now the difference has to be exact. You cannot supply any amount of energy if you want to move it from the first orbit to the second. Eventually then what happens is this electron will release that photon and come back to where it actually belongs. This phenomena is called as de-excitation. Did you people get that? Any questions over there? Please write down. The energy of an electron, the energy of an electron in the orbit, the energy of an electron in the orbit does not change with time. Full stop. Continue. This means that the energy of an electron in a particular orbit, remains constant. That is, it does not lose or gain energy. Next point. The electron will move from a lower stationary state to a higher stationary state, when the required amount of energy is absorbed. When the required amount of energy is absorbed. And when the electron jumps back to lower energy level, it emits the same amount of energy. Thus, energy change does not take place in a continuous manner. Next point. As long as an electron is revolving in an orbit, where it does not lose or gain energy, such orbits are known as stationary orbits or stationary state. And when the electron moves in the least possible energy level, and when the electron moves in the least possible energy level, it is known as ground state. It is known as ground state. And when it moves on to the next energy level, and when it moves on to the next energy level, and when it moves on to the next energy level, it is known as excited state, first excited state. It is known as first excited state. The higher energy levels are known as second excited state, third excited state, and so on. The higher energy levels are known as second excited state, third excited state, and so on. Okay, so when the electron is present in the first state, we call it as ground state. If it gets excited from the first state to the second state, n is equal to 2, then it is called as the first excited state. If it goes to n equal to 3, what will you call this as? Second excited state. If I take this further, n is equal to 4, what will you call this as? Third excited state. So on and so forth. Okay? The ground state is also called as stationary state. Did you people get that? Quickly copy this. Go back to the second postulate and tell me, when we equated centrifugal force and force of attraction, तो हमको क्या equation मिला था? Left में हमने क्या लिखा था? K ZE squared over R square था, the first one, which was equal to mv squared over R. ठीक है? And when we wrote angular momentum is quantized, what was the equation that we wrote? जब हमने लिखा था angular momentum is quantized, mvr is equal to nh over 2. जहाँ पे आपने लिखा है ना angular momentum is also represented as L. Please ये लिख के रखना वहाँ पे. So that mvr is actually L. I missed that. Second thing is, side में ऐसे mention करो h upon 2 pi can also be written as h with that cap. And so mvr, which we wrote as h nh upon 2 pi, this mvr can also be expressed as n h bar. ठीक है ना. Okay. Now from these two equations, छोटा सा एक derivation करना है. What is velocity from here? V is equal to n into h upon
MR.
2 pi. What will I move to the right?
MR.
M and R. Now take the first equation. And in the first equation, जब हमने R cut कर दिया था, what was the equation? K ZE squared upon R is equal to MV squared. If I take R over here, what do we get? K ZE squared over MV squared is equal to R. Any questions still here? Why we just did this is because what do we get the expression for R? We're going to put that over here. This is NH upon 2 pi M into 1 over R. Can I write it like that? Respond yes or no. थोड़ा सा अपना काम सिंप्लीफाई करने के लिए instead of finding R, can I take this kz e squared to the denominator? So 1 upon R can be written as mv squared upon kz e square. Where will I put this 1 upon R? I can put that here. So tell me क्या मिलता है people? V is equal to what is this? N into h over 2 pi m into mv squared by kze squared. कुछ कैंसिल हो रहा है कि कहीं पर? I'll write this again और फिर कैंसिल करते हैं. क्या कैंसिल हो रहा है? This m and this m. Anything else that you see? यहाँ पे v, यहाँ पे क्या है? v squared. Anything else that you see? So left में क्या बचा? 1 is equal to nh upon 2 pi into v upon kze square. I'm sorry. We're looking for the formula of velocity. What do you get v from here? I take 2 pi to the left, so 2 pi k z e square upon n into h. Now 2 is a number, that's a constant. Pi is also a constant. How much is k? 9 into 10 raised to 9 Newton meter square over Coulomb square. What does Z stand for? Atomic number. What does E stand for? Charge. Magnitude is 1.6 into 10 raised to minus 19 coulombs. What does N stand for? Orbit number. What does H stand for? Planck's constant. So, in all of this, कौन से कांस्टेंट टर्म्स है? I repeat, the terms which are constant. Is 2 a constant?
Yes.
Is pi a constant?
Yes.
Is k a constant? Is the value of E a constant? Will the charge of an electron change? Is it something different in chamber and different in Bandub? So, E squared. Is Z a constant? Will Z change depending upon what atom you have? Z. और कुछ बचेगा न्यूमरेटर में? Is n a constant? Orbit number can be 1, 2, 3, so on and so forth. What is left?
H.
What is H? Planck's constant. This entire term is a constant, or you can say velocity is directly proportional to atomic number and inversely proportional to the orbit. So I have a question. Which electron is moving faster? The electron present in the first orbit or the electron present in the second orbit? It is inversely proportional to n.
First orbit.
So the electron moving in the first orbit. Or let's say I compare hydrogen with lithium, both the electrons in the first orbit. Which electron is traveling faster?
Lithium.
Hydrogen or lithium?
Lithium.
Lithium is traveling faster because Z for lithium is 3 and for hydrogen is 1. Did you people get that? When you substitute all the values of constant, you get V is equal to 2.18 into 10 raised to power 6 into Z upon N meters per. That's the formula for velocity of an electron in Bohr's atom. अब इससे आप यूज करके you can find the velocity of any electron. Now, Rutherford का another drawback, such mathematical proofs were not given by Rutherford. For example, I want to know what is the velocity of the first electron in hydrogen atom. So, what is Z for hydrogen?
1.
What is N?
1.
So, what will the velocity be? 2.18 into 10 raised to 6 meters per second. Find the velocity for me, let's say for electron in lithium.
3.1 to 3 into
So क्या आएगा 2.18 into 10 raised to 6. Lithium atomic number n is equal to 1. You can put n is equal to 2 depending upon question क्या पूछता है. We'll do some sums अभी. Did you people get that? Sometimes this is also written as V is equal to V naught into Z over N meters per second, where what is V naught? 2.18 into 10 raised to 6. Any questions in the derivation of velocity? Chalo. Now look at the same formula again. I go back and I write the same formula for angular momentum. क्या angular momentum का formula? mvr is equal to n into h upon 2 into pi. We had kept velocity here. V को इधर रखा था and m and r को we had taken to the right. Now keep r here and move m and v to the right. So what do you get? R is equal to nh upon 2 pi into 1 upon mv. NH upon, I write 2 pi m together into 1 upon V. What is the expression for V? Substitute the expression for V over here. What do you get? R is equal to NH upon 2 pi m into,
H by 2K.
can I 1 upon V है, so everything will become उसी का reciprocal, so denominator में you add H, that will go to the numerator, H upon 2 pi K E squared into N over Z. Anyone who did not get that? Next, R is equal to N into this N becomes N squared H square, denominator 2 pi 4 pi squared m है क्या और कोई? No. K, any other K? Not there. E square, and क्या बचा है उधर? Z. Is n a constant? No. Is H a constant? Yes, उसके नाम में है Planck's constant. H squared. Is 4 constant? Pi square m K E squared and you're left with, this is the formula for radius. Any questions still there? So just like velocity was directly proportional to Z and inversely proportional to N, can someone give me the same expression here? R is directly proportional to N squared, inversely proportional to atomic number Z. All the values remaining the same, substitute किया तो R का formula मिलता है 529 into N square upon Z. The unit is angstrom. How much is an angstrom in meters? 10 to the power minus 10. Did you people get that? Now tell me the relation between radius and Z. I want to compare the size of hydrogen and lithium, or let's say if I go in the same period, I want to compare, let's say, nitrogen and chlorine. किसका atomic number ज़्यादा है? So as the atomic number increases, radius decreases, which you have studied in periodic table in the form as you move from left to right, size decreases. Periodic table में आपने पढ़ा, as the number of shells increase, the radius increases. Did you people get that? Yes or no? Now, let's continue with some easy questions. So, we'll start with, let's say, this one first. Calculate the radius of first, second, third, and the fourth Bohr orbit of hydrogen atom. What's the formula for radius, people? Radius is equal to 0.529 into n square by z. Angstrom. Now they've said it for hydrogen atom. So if we do it for hydrogen atom, what will z be equal to? 1. So formula को थोड़ा modify करके कैसे लिख सकते हैं? R is equal to 0.529 into n square angstrom, since z is 1. Next, for the first orbit, so n will be 1. What will the radius be, people? 0.529 angstrom. For n is equal to 2, radius will be 0.529 into 2 square, which is 4. Multiply, I hope आप लोग कर सकते हो. N is equal to 3. R will be again 0.529 into 9, 3 squared. And for n is equal to 4, radius will be 0.529 times 4 square. Okay? I think you people can do that for me. Chalo. Now, we'll discuss the second question and then एक साथ दोनों को आप complete करना. What does the second question say? Calculate the ratio of radius of second orbit of hydrogen atom to the third orbit of lithium atom. तो दोनों को क्या निकालना है people? Ratio. What do we have to first find? Second orbit of hydrogen atom. I repeat, second orbit of hydrogen atom. Radius का formula हमारे पास already है यहाँ पे. Second orbit of hydrogen, so I'll write it as R of H. We're saying second orbit, which means n is equal to 2, z is 1. So radius will be 0.529 into 2 square. I'll keep this as it is. 0.529 into 4. There's no need to multiply. Radius of the third orbit of lithium. Third orbit of lithium ion. So what is the value of n over there? 3. But what is z? Z is also 3 because it is lithium. Substitute karo. So what do you get? Radius of the lithium ion will be 0.529 into 3 square over 3. Or basically that will become 0.529 into 3. Anyone not get that? Next क्या निकालना है people? We have to find the ratio of this, which means it's the ratio of radius of hydrogen over radius of lithium. How much is the radius of hydrogen? 0.529 into 4 over 0.529 into 3. So what do you get the ratio as? 4:3. You will get that. Copy this for me jaldi, then we'll do some more sums. Okay. So what does the question say, people? The radius of the second orbit of lithium ion is x. What's the formula for radius? R is equal to, now instead of 0.529, we can write R0 into, what is the formula for radius? n square by z angstrom. Now they're saying that the radius of the second orbit of Li2 plus. Second orbit का radius how much they've given is x. ठीक है, I'll write it here, radius of second orbit. Now फॉर्मूला में पुट करो, मेरे को बताओ the actual radius कैसे निकालेंगे. Radius would have been r naught into, when they say second orbit, n का वैल्यू कितना है 2. How much is z?
3.
It is lithium, so it is 3. How much will that become? 2 square over 3. Or how much is that? 4 r naught over 3. And how much is that radius equal to given? It is given equal to x. Therefore 4 r naught upon 3 is equal to, how much do we get r naught from here? 3x over 4. Second part. Then what is the expected radius of the third orbit of beryllium plus 3? Third orbit of beryllium plus 3, what will the formula be? R naught into, since I want third orbit, n will be 3. How much is z for beryllium? 4. Let's put that here. क्या मिलता है people? R naught into 3 square over 4. But how much is R naught that we've got from here? So 3 over 4x into 9 by 4. Total कितना होता है? 27 by 16 x. That is the answer. Anyone who did not get that? Any step? Pause कर देना. Oh. The expression of kinetic energy of electron in the second Bohr orbit of hydrogen atom is, first of all, can anyone tell me what is the formula for kinetic energy? Half mv squared. Okay. Now if you look in the options, we need h. H stands for, I need pi, I need m. We've learned only one formula which has h, which has pi, which has m. कौन सा formula पढ़ा है हमने? We have learned a postulate जहाँ पे एक simple formula है which links m, v, r. Which formula is that? Angular momentum is quantized. कौन सा formula है वो? m, v, r is equal to nh upon 2 pi. We've learned this. I need h in the numerator, मेरे को पता चलता है. So what I do from here is, in the entire formula, in all the options, I'm sorry, there is no velocity. कहीं पे velocity दिख रहा है क्या? v, which means from here I need the expression for v. What is the expression for v? n h upon 2 pi m r. Put that here. So what do you get? Kinetic energy as half m nh over 2 pi m r, the whole square. With me till here? चलो square करो उसको. half m n square h square upon 4 pi square m square r square. Thoda we are coming close. Now my formula here is r, but in the options they are looking for r naught. How do we link r and r naught? We know that कहाँ पे तो लिखा है r is equal to r naught into z upon n, sorry, n square by z. So r naught into, how much is n for this second Bohr orbit? So I can put 2 squared. And how much is z? Why 1? Because it is, तो ये कितना हो जाता है 4 r naught. With me? Similarly यहाँ पे भी there is an n. वो n की जगह पे भी क्या आने वाला है people? 2. So finally kinetic energy is equal to half m, what is this, n? 2. So 2 square will become 4h square upon 4 pi square m square into r square. But r is how much? 4 r naught. So that square will become 16 r naught. कुछ कैंसिल हो रहा है क्या? 4 ones are 4, 4s are. So how much do we get the final expression as? ऊपर कुछ बचा क्या है? ये भी m कट हो रहा है ना? m. So ऊपर सिर्फ क्या बचा? h square upon, what do we have? 442, which is 32 pi squared m r naught squared is option C. Did you people get that? Copy this. We stop for the day. Next class we continue with Bohr's postulates. There are still Bohr's postulates left. Most probably next class भी Bohr's postulate में ही जाएगा. ठीक है? Thank you people. अरे मैंने बटन स्टॉप की जगह पे